Right, this is my video for sheet B. Question 1. For this we use the equation E equals hc over lambda. So you get E equals Planck's constant 6.63 10 to the minus 34 times by C 3.0 times 10 to the 8. We divide this by the wavelength, which is 6.3 times 10 to the minus 7, which gives an answer of 3.2 times by 10 to the minus 19 joules, which is about 3 times by 10 to the minus 19 joules. Part 2. Right, for this, number of photons, n, is the power divided by the energy of one photon. So this equals 1 times 10 to the minus 3 watts divided by the energy of a photon, which in this case is 3 times by 10 to the minus 19, which equals 3.3 times 10 to the 15, which is about 3 times 10 to the 15. So there's your answer. Now the next question asks us to explain what energy levels are and how they can be used to explain the emission of photons from atoms. Right. So here is a simplified atom with electrons in the energy level. Electrons can be in different energy levels, which means they can release different photons with different energies. So when this atom hits red light, an electron loses energy and makes a transition from a higher energy level to a lower energy level. This transition releases a photon. The energy of this photon is equal to the energy difference between the two energy levels. So if we had a higher energy level, then the photon will be more energetic. Part 4. Red light has a much lower frequency and a much longer wavelength, whereas blue light has a much higher frequency and a much shorter wavelength. So from the equation E equals hf, if we increase f, then the energy will also increase, so less photons will be needed for a power of 1 milliwatt. Question B asks us to show an arrow of the direction that electrons move in this photodiode circuit. The arrow would go this way as the electrons will move, because electrons are negatively charged, so they'll be attracted to the positive end of this circuit. Now for question BI, to find the current in the circuit, we'll need 20% of the photons, so 20% of the number of photons equals 6 times by 10 to the 14 photons, and because every photon releases only one electrons, this is the number of electrons released. So from the equation, current equals charge divided by time. The total charge will be 6.0 times 10 to the 14 times by the charge of one electron, which is 1.6 times 10 to the minus 19, divided by 1 for 1 second, which equals 9.6 times 10 to the minus 5 amps. Then for part 3, suggest one reason why the efficiency of the photodiode is less than 100% is because some of the photons are absorbed by the electrons or by the conducting layer. Thanks for watching.